And now we shall study some important theorems on composition of function. And the first theorem is the composition of two bijections is a bijection. That is, if f and g are two bijections, then GOF is also a bijection. Now suppose the function f from a to b and the function g from b to c are two bijective functions. And suppose the composition of f and g is defined as GOF from set A to set C. Now GOF will be a bijection if it is injective as well as surjective. So let's first check whether this function is injective or not. Now suppose x and y are two elements from set A. Now GOF will be injective if GOF of x is equal to GOF of y, and then that means x is also equal to y. And now let's check whether x is equal to y. Now g of f of x is equal to g of f of x. Or we can write g of f of x is equal to g of f of y. Now g is a bijective function, so it is injective. So in case of injective function, if g of f of x is equal to g of f of y, then that also means f of x is equal to f of y. Now again, f of x is also a bijection. So that means it is injective. And if function f is injective, then if f of x is equal to f of y, then that means x is also equal to y. So that means if GOF of x is equal to GOF of y, then x is also equal to y, or x is equal to y. That's what we wanted to prove. So that means GOF of x is equal to GOF of y for all x and y which belong to set A. So that means GOF is injective function. Now let's check whether GOF is also surjective or not. Now G of f will be a surjective function if for every element z which belong to set C, then there is always present an element x which belong to set A such that GOF of x is equal to z. Or in other words, every element in set C must have a pre-image in set A. Now z belong to set C and y belong to set B, then that means g of y is equal to z. Now y belongs to set B and x belongs to set A. And if x belongs to set A, then f of x is equal to y, because f is a bijection and every bijection is surjective. So then that also means for every element z which belong to set C, then there is always present an element x which belong to set A such that GOF of x is equal to g of f of x, which is equal to g of y, and that is equal to z. So that means every element z in the function GOF has got a pre-image in set A, and that is the precondition for a function to be surjective. So that means GOF is a surjective function. Now GOF is injective as well as surjective. So that means the composition of function f and g defined as GOF is a bijective function. Or we can say the composition of two bijection is a bijection. Now let's discuss one more theorem. Let f is a function f from a to b and g is another function from b to c, then g of f from a to c is onto, then that also means the function g from b to c is also onto. And the second theorem is, if g of f from a to c is one-to-one function, then that also means the function f from a to b is also one-to-one function. Now here we are given that g of f from a to c is an onto function, which means for every element z which belong to set C, there always exists an element x which belong to set A, so that g of x is equal to z, or we can write g of f of x is equal to z. Now f of x is equal to y, or f of x belong to set B. So we can write g of y is equal to z, where y is equal to f of x which belong to set B. So that means for every element z which belong to set C, there always exists an element y which belong to set B, or every element z in set C has got a pre-image in set B. So that means the function g from B to C is an onto function. Now in the second case, we have to prove f from A to B is one-to-one function. Now f from A to B will be a one-to-one function if f of x is equal to f of y, then that also means x is equal to y for all x and y which belong to set A. Now suppose xy belong to set A and f of x is equal to f of y, or we can also write g of f of x is equal to g of f of y. Why? Because g is a function from set B to set C, or we can write g of f of x is equal to g of f of y. Now g of f is a function from A to C and it is also one-to-one function, which means if g of f of x is equal to g of f of y, then x is also equal to y. And that's what we wanted to prove. So that means if f of x is equal to f of y, then x is also equal to y, where xy belong to set A. So that means the function f from set A to B is a one-to-one function. So that means if g of f from set A to C is one-to-one function, then the function f from A to B is also a one-to-one function.